We discussed last time that the tilt of the Earth going around the sun makes the seasons. Well, let me address something else that's interesting here. And that is that as the Earth goes around the sun, we also know that it has a little bit of an elliptical orbit. And that turns out to have an interesting sort of effect on the year and the motion of the Earth around the sun. Now, when I say that it has an elliptical orbit, students often kind of like think, well, okay, that might have something to do with seasons. So the orbit is elliptical. And so when we describe an elliptical orbit here, the closest that an orbit comes to the thing it's orbiting is called periapsis. The farthest it is from what it's orbiting is called apapsis. Now, the sun, Greek for sun is helios, and so perihelion is the closest we get to the sun, and aphelion is the farthest we get from the sun. Now, the interesting thing here is that the way this orbit works, I mean, think about it. What makes the Earth go around the sun? Gravity. Where's the gravity stronger? Where we're close. And so that means that it actually goes faster here than it does out here. So this part of the orbit actually takes less time than the other part of the orbit. And we'll get back to that in just a little bit. But the question is, when are we actually closest to the sun? And so you think about that, and a lot of students, actually get the answer wrong. In 2017, we were closest to the sun. Perihelion occurred in January 4th, and aphelion was July 3rd. Okay, and then these were the distances right there. The following year, that changed slightly. So we were closest January 3rd, we were farthest July 6th. And then the following year, that again changed slightly. Closest January 3rd, farthest July 5th. And then this year it changes a little bit, closest in January 5th and farthest July 4th. Your syllabus actually is going to give you the closest for the next year. And so you notice that it's always early January that we're closest to the sun. So that's the perihelion. It's always in January. And the aphelion, the farthest from the sun, is always in, on the other hand, it's always in July. So what does that mean? Well, it means exactly what I was saying, that the distance from the sun is not really the important thing, but the angle that the sunlight hits Earth, and because of the tilt of the Earth, we call the inclination of the Earth, that tilt is what causes the seasons. We're actually closest to the sun in January, we're farthest in July. So the tilt causes the seasons. Well, in a little bit of ironic cruelty, remember I said that when you're farther from the sun, the orbit runs slower. When you're closer to the sun, the orbit runs faster. Well, when are we closest to the sun? Well, close to the sun in January. When are we farthest to the sun? July. Oh, we go slower when we're farther. You ever get the feeling that the summers in Texas are very long? Particularly if you have to be out in the heat. The summers just seem awfully long. Well, it's not really your imagination. If you actually look at a calendar and count how many days are in the summertime and how many days are in the wintertime, the summer months are the summer is longer. I mean, from the vernal equinox to the autumnal equinox is the spring summer months, the hot months, they're about a week longer than the cold months. And the reason for that is, well, assuming you can actually define cold in Texas, but the reason for that is that that's the slower part of the orbit. Now, it's not just Texas, it's in the entire northern hemisphere is that way. And so that again, this is one of these little factors that a lot of people don't really think about. It's like a footnote to this whole orbital motion here. And the orbital motion is due to the tilt that changes things. You've got the annual motion that gives you the orbital motion, gives you annual motion. The annual motion, because of the tilt, gives you the seasons, and then the elliptical nature of the Earth's orbit, complicates things just ever so slightly.